Okay, Sarah, Amit, should we start?
Yes.
Let's do it.
Okay, great. So hi everyone, I'm Ido. I'm with lakeFS, and I have two great folks here with me, Amit and Sarah. At no particular order, if you guys want to introduce yourselves, go ahead.
Sarah, you go first.
Sure. My name is Sarah. I do growth marketing at Prefect, which is a workflow orchestration tool, which you'll hear a little bit about during this webinar. My background is in data engineering. I led a data engineering team at a fintech company, and so I'm very excited to partner with lakeFS on this.
And I'm Amit Kesarwani. I'm solutions architect with Treeverse. Treeverse is behind a project called lakeFS. And my background is also database, data engineering, and machine learning. Thank you, Ido. Back to you.
Okay. Yeah, great. So yeah, we're here to talk today about troubleshooting and reproducing data with Prefect using lakeFS. So we think that there is a huge integration, very powerful integration of the two solutions together. So Sarah, we're so happy to have you here. Thank you for joining as well. Just a few housekeeping rules before we start. This is broadcasted on Zoom and on LinkedIn. If you have any questions, please feel free to use the Q&A. Everybody is anonymous. When you ask a question, your name might actually appear. So I think you can choose to be anonymous. And if you do that, go ahead and we won't see who you are. But if you don't mind, you can share your name also. Please feel free to ask questions as we go. We will record this session and also share with those of you that registered the recording at the end. Yeah, but before we begin, we obviously want to speak today about Prefect and lakeFS and reproducing data. I do want to open the poll quickly and kind of ask quickly, if those of you that are on, if you can answer, are you familiar with lakeFS? Are you familiar with Prefect? And what are the roles that we have here? So I'm going to wait 15-20 seconds. If you guys can answer the poll that's in front of you, that will be very, very helpful. So we'll know if we should spend some more time explaining what Prefect is, or some more time explaining what lakeFS is, or just go on average. So I'll give this 5 more seconds if everybody can answer. Okay. Okay, thank you. I apologize to say this, but I don't have people are somewhat familiar. So so Sarah, if you want to maybe start and kind of let us know what Prefect is, and assume that the folks on the line are not necessarily familiar with what Prefect is.
Yeah, awesome. So I do want to, we'll make this just an effort of getting everyone on the same page. So Prefect is a workflow orchestration tool. If you think about we need to schedule Python or SQL work, what happens? Prefect, we like to think about when you actually access our tool, which is usually when your workflows fail, which is why we're really excited about this webinar. So out of the box, you can schedule your workflows across your stack and reduce those debugging times through a UI where you can understand all your logs in one place, your summarized logs, and really connect all your different Python work to understand the dependencies between it. And now moving to the development side of things, right? Python, we want to stay directly in Python as opposed to needing to write your workflows in a domain-specific language. So that's where the development time using Prefect is reduced, because you're really just sticking with what you know, which is Python. If you think about all of the different needs that you might have when developing workflows, and that's both in debugging and in infrastructure. So we like to be as versatile as possible. So now I'm excited to turn it back to the Treeverse and team about lakeFS to really dive into like what happens when your workflow fails.
Yeah, so that's awesome, and thank you. And I think it's very part of the reason that we think that there's a powerful integration here is that you had in mind kind of the I guess, life cycle management, going from prod to dev sometimes, but from dev to prod, all the way through different things, and making it easier for your users. And that's definitely one of the areas that we play in, of course, on the data side and not on the orchestration side. So there is a better together here. But I guess there's a bunch of folks with us here today that join us to talk about troubleshooting, issues in production with data. When you use Prefect, one of the awesome things is that you start by doing this very simple flow, and then as you get more comfortable with Prefect, you can do more and more and more things. And by the way, these are like far smaller than what we see in the field, right? I remember Amit and I once went with on a call, and the person on the other line had to Zoom for like 10 minutes until we got to a specific point. And the question is, and I guess this is a question for you, Amit, what happens when this turns red, and now I want to troubleshoot and see what happens?
Yeah, and traditionally, if any task fails in any your pipeline, data pipeline or ETL pipeline, you basically go first to look for the error message, look for the error logs, try to figure out what were the dependencies which caused this error, and whether it was caused by some data issue, or if it is a data issue, then you try to do a traverse your data problem or lineage and see how the data evolve over time from one task to another, and then try to fix the data problem. Fix your data and then rerun your job and hope and pray that everything will go fine. So that's normally people traditionally do.
Yeah, hope and pray is a great way to do things. But in reality, we see this all the time, right? We don't there's this massive, complicated pipelines that you can run with the help of Prefect, which is fantastic because there's absolutely no possible way that you would be able to do it without a very strong orchestration solution. But that means that when something breaks, the complexity, that's when you pay the price for the complexity that you were able to achieve, right? So here is where lakeFS comes into play. For those of you who are not familiar with lakeFS, and there's a bunch of you here as well on the line that are not familiar with lakeFS, what lakeFS does is it sits on top of an object store that can be S3, Azure Blob, Google Storage, but it can also be an on-premises object storage like Min.io or Dell ECS or NetApp Storage Grid, right? And imagine that you can take a bucket or a collection of buckets and you can give them a Git interface, like you can branch your data, right? So imagine that you already run your flow on a branch. As you make changes, you commit. If you're unhappy, you can roll back. If you are happy, you can merge the changes, kind of running data as code. And then the ecosystem of solutions that we have in our environment can access the data through the lakeFS API and get those versioning capabilities with a very minimal refactoring, right? If before we're accessing a collection on a bucket, now we will basically include a name of a branch or a commit identifier. A name of a branch can be prod, test, dev, or a specific, transformation that we're doing, a data set that I'm trying to work on. And a commit identifier can be production yesterday at 5 p.m. before I ran the ETL, or production yesterday at 6 p.m. after the ETL finished. Then the way that it works is we actually take advantage of the fact that the object store is immutable. So again, we work on top of data lakes, and you will have your bucket. This would be your bucket sitting within your VPC, and you probably have like a bunch of files here. And the format doesn't matter. This can be Parquet files, images, annotations, videos, iceberg tables, delta tables, doesn't matter, any format whatsoever. Every commit in lakeFS is a collection of pointers to objects that sit on top of this managed bucket. Now, because the object store is immutable, we do copy and write. So when a new file is created, the next commit will point to that additional file. But files that did not change, like these 3 files in this examples, you will have multiple commits pointing to the same physical objects. Why is this particularly powerful in the scenario that we're speaking about right now? Because I want to run a long-running ETL using an orchestration tool, I want to create a copy of my data, right? A branch. This will be a metadata-only operation, which means that I'm not copying any files. For that reason, A, at hundreds of petabytes of lakes, this will take milliseconds, and B, it will take milliseconds, and B, it doesn't cost additional storage. So you can run all these transformations in parallel across different parts of your flow without the need to actually copy any individual file. And furthermore, if you want to roll back, by nature in data lakes, a lot of the files are static, and then a much smaller subset of the files are added or removed. So you actually de facto deduplicate the object storage over time, and you can go back in time without the need to take snapshots of the same files over and over again. So that's what we do, and we want to show it to you today. We want to go quickly into a demo, and we want to show you a few things. We want to show you how you can set up lakeFS with Prefect very easily. We have a sample that's already prepackaged, and then we can show you two things. A, running a flow in isolation, right? So imagine that you have your transformation, your pipeline that you run as a part of Prefect. You're going to create a branch, run that pipeline, and then merge it. That gives you not only the easy promotion that you have using Prefect to promote the code, but it also gives you the ability to promote data. So I made changes to 50 tables, and when I'm done, I'm going to promote the data. It also gives me a very easy way to roll back. In the second demo that we're going to show you today is the ability to actually execute Git actions within a flow. Why is that important? That means, going to the very beginning of our call, that if something fails over here, in step 54 out of 100, I can go and see the data set as it was at that specific section. So that's kind of what we're going to go and see. Two examples using lakeFS against a Prefect existing flow, or writing a new flow with lakeFS using these Git commands within the flow itself. Amit, I'll pass it on to you.
Excellent. Thank you. Let me share my screen. And I'm going to hide my Zoom control. So if you see any questions, let me know, Ido. Okay. So as Ido mentioned, we have this sample repository, which includes both lakeFS as well as Prefect. So whatever I'm going to show today, the whole demo is everything is packaged in a container. So if for this to run on your own, you will need the Docker. I'm running Docker on my laptop, and also need Git. So first thing is go to our sample repository. This is a link, and you can scan this QR code. So let's go to the sample repository here. And all the instructions are available in this sample repository. This is just a Prefect integration within our samples. And you can find the instructions here. So you will just git clone this repository to your laptop, and then run the Docker compose. So that will start your container. Right now I'm running those containers, and that container, the group of containers will include the Prefect server, as well as the database required for Prefect, and a Jupyter notebook container, which includes the notebook to run this demo. So that's the initial setup to run this sample demo notebook. And you will also need a lakeFS for this to run. If you want, you can run lakeFS locally as a container. So if you run this command, this will spin up your lakeFS container locally, or you can use lakeFS Cloud. It's easy to sign up for lakeFS Cloud. So let's do that. And we provide this lakeFS Cloud for 30-day trial along with the object store. So you don't need to use your own S3 bucket or Azure or GCS. You can use the bucket provided by us in lakeFS Cloud. So I already signed up for this. So I'm going to log in directly to my lakeFS Cloud. Otherwise, you just provide the email and password and create your account. It takes just a few seconds to spin up your lakeFS server instance. And you'll also receive this email to verify your email address. When you provide the email address, we'll send you email to verify so that you can access your lakeFS Cloud account. Okay, so let me log into my lakeFS Cloud account. This is my account email I use. So let's log in here. And in the lakeFS Cloud, we provide additional functionality like role-based access control, single sign-on. That's what you saw, the single sign-on I'm using on my Okta account. So that are additional features we provide in lakeFS Cloud. So once you sign up for the cloud, by default, we'll spin up a cluster, a lakeFS server for you. And you can also configure this to connect to your object store if you want to. But by default, we'll provide you the object store also behind this server. So this here, once it is running, the server is running in it takes about 10 seconds to start. And then click on this link, and it will take you to the lakeFS server instance. And again, so this is my lakeFS server environment. Currently, I have 2 repos created here. So by default, when you log in, you'll see a sample repo. And as I mentioned earlier, we also provide the S3 bucket in this case, so you can test with lakeFS Cloud. Or if you want, you can also, as I mentioned earlier, you can connect your lakeFS server to your own object store also. And I just want to add that when you connect to your object store, data stays in your object store. Data never comes to the lakeFS Cloud. Data as well as metadata that we create, everything will go into your object store if you connect to your object store. But in this case, we are providing this. When you sign up, you'll get a sample repo along with this storage bucket that we provide.
So you go to lakeFS Cloud, you spin up a lakeFS instance, and then you have part of the environment. And then how do we get the beautiful Prefect?
Yeah. So now we have the whole environment ready. So we got my notebook environment. So if I go back to my containers here, you'll see all these port numbers. So this is for the Jupyter Notebook. Just click on that. It will click you to that Jupyter Notebook environment. It is, again, as running in this container. Everything is contained in this example here, or in this container here. Okay, so now we have the environment ready. We have our Prefect server. I have lakeFS Cloud environment ready. And then we have these 2 sample notebooks. So let's look into those 2. So the one is the Prefect demo existing pipeline or existing DAG. Another one is the new DAG. As Ido mentioned earlier, let me explain both those notebooks. So the first one we'll show is where, let's say you have existing Prefect pipeline or flows, and you want to run that in isolation from your production environment. So you don't want to run your ETL job in production. You want to run that in an isolated environment where we'll create a branch from the production. As Ido mentioned earlier, creating a branch in lakeFS is a millisecond operation. We don't copy any data. We use pointers to those files in your production environment. Unless you change something, that will happen in this branch only. So in this case, you'll run your Prefect job isolated in a separate branch. And once the job finishes, and if it is successful, then you will merge that job into production. So let's say in particular job, you might be changing lots of files, lots of table, hundreds of table. When you merge into production, everything is atomic operation. So all at once in a millisecond operation, all those changes are available to users in production. So when you're running your ETL job, you're not impacting your production users until everything is ready, and then you atomically promote that all the changes into production instantaneously. So that's the one demo I'm going to show, the first one. In the second demo, let's say you have a very complex pipeline or complex flows, and in each task, you want to kind of maybe commit the changes you make in your data so you can see the full data lineage going from one task to another. And also a lot of tasks you can run in parallel. So here you might create different branches and run these things in parallel and track all the changes separately. So what that helps you is if something fails, let's say one task out of 2,000, 100,000 tasks fail, you can see the full data evolution or data lineage and see what changes happened before that task failed. So you can see what changes happen, and then accordingly you can fix the problem. and then rerun the job without, like, while this thing is running, you are not impacting your production users because everything is running in an isolated branch. And once you fix your job, rerun the job, and then once it is done, then you merge your changes back into your production. Anything else, Ido, you want to add?
No, I think it's really great. I think the idea here is that if you already have something, all you need to do is wrap it with lakeFS on the sides, and then you get three things as you called out. A, you get atomicity, right? So if you change 20 tables, you will atomically promote all of them. B, you get isolation, meaning if something failed, then you actually didn't expose anything to the production data. And C, you get if that's a word in English, rollability, right? Rollbackability. If you didn't catch a problem and you promoted bad data, it's very easy to just go atomically throughout all the changes back to before I ran the transformation. And that's something that you can do literally in minutes. And then the second example, as you said, it's maybe a little bit more work, but it's far more lineage capabilities.
Okay, good job. Thank you. Yeah, I forgot about the rollback feature. Like, that's also very important. If something you bring into production, if it is wrong data, then you can quickly go back to the historical commit. Okay, so now let's look into these demos. So first one, we are going to, if you have existing pipeline, we'll just create a wrapper around that and run that the job or flow in the isolated branch. So here we are using integration between lakeFS and Prefect. And for that, we are using a community-built integration library. So if you go here, so I will just quickly open this. So this is the Python library that we are using, which does the integration of Prefect and lakeFS. lakeFS, we also provide a Python client. So if you want to use our Python client, you can use that, or you can use this library, which internally uses our Python client also. So this adds some additional functionality and features on top of the lakeFS Python client, and I'll walk through that.
I'll jump in for a second. There was a question on the chat. I answered also there. Are we speaking about merging data? Correct. We're talking about making all the changes in the data atomically, and then when we're done, merging the data changes back into prod.
Yes, it's not just the code. You can manage your code in the Git, and manage your data, version control your data using lakeFS. Okay, so let's start with this notebook. I think we have everything ready now. So first thing is in your Python code, and this, for example, this notebook, provide the credentials to connect to your lakeFS server. If you are running lakeFS locally as a container, a Docker container, these credentials are good enough if you install from the sample. But if you are using lakeFS Cloud, you can, let's get the lakeFS endpoint. So this is my endpoint here, lakeFS endpoint. So let me copy this. Okay, and let's create the access keys. So if you go to the administration here, lakeFS Cloud UI, go to administration, you can create an access key. I already have one, but let's create a new one. And this is my access key. So let's copy this. And let's get the secret key. Okay, let's run this. So this is setting up the credentials to connect to lakeFS. The next thing is the storage namespace, where you will create the lakeFS repository. This is the S3 bucket or Azure or GCS bucket or any object store you use, where you want to store this lakeFS repository. Your data might stay in a different bucket, or data might stay in a same bucket. It's up to you. So here, what we can do, you can, as I mentioned earlier, you can connect to your object store, but in this case, we are going to use this object store provided by lakeFS Cloud. So you don't have to bring your own object store for testing this. So as I mentioned earlier, this is the object store that, or the S3 bucket that we provide. You can just copy here and add the additional folder or prefix within that. So here, let me call this some repo.
It's worth mentioning that every repository in lakeFS should have a unique storage namespace. So if you run this a couple of times, make sure to take care of that.
That's good. That's good. Yeah. So just added one folder, subfolder here within this storage. So let's specify this variable, the storage namespace. And the next thing is specify the repository name. This is already here in the sample, but you can change the repository name. And just quickly, I'll walk through. If you want to create the repository, you can create the repository from the UI also, or you can create through the Python API. So again, when you create from the UI, you specify the repository name, your production branch name, default is the main, and your storage namespace. Just quickly give sample here, like when you create the repository, I'll just walk through the UI quickly. You have all your data stored in the lakeFS repository. Here I have the main branch, which is my production branch, but you can create your own branch from the UI or through the API. In this case, I have created multiple branches to run my pipeline. And then once you upload your data into lakeFS repository, by default, it's uncommitted changes, and then you can commit your changes. I'll show all these different commits, so where we can keep track of all the lineage, and you can look into what changes happen with each commit. So that's very kind of high level how the lakeFS looks like. Let's go back to the demo here. Okay, so now I got my credentials to connect to lakeFS repository from my Python client. Next thing is using this Prefect and lakeFS integration library. You can store those credentials in Prefect block. If you're familiar with the Prefect, you can store these credentials in the block, so you don't have to pass on these credentials every time, and you don't have to expose the secret key all the time. So let me also go to my Prefect UI here. So let me just quickly store these credentials into the Prefect block. And if I go back here, look at my block here. So these are my credentials, and secrets are hidden here. Okay, so next thing is going to run some setup task, which what it's going to do is it will make the connection to lakeFS server, make sure we can connect to lakeFS server, and then create this repository in lakeFS. So if I go back here, so now I should have another repository here called Prefect existing DAG repo. So this is my new repository. So right now there's nothing in there. It's all empty. So it's a blank repository. Next thing what we are going to do is run your existing DAG or existing flow and in a separate isolated environment. So we provide a wrapper DAG or wrapper flow. I'll walk through that and what it does. So let's say if you have an existing your ETL job, so this is a very simple job. Let me walk through this. Again, this is all Python code. So here we have an ETL process, extraction, transformation, and load. And this, it's a very simple example where we have the order ID and the order amount here as a data string. So there are 3 orders with the amount. And that in the transformation, what we are doing is we are calculating the total order value. So sum each value to get the total order value, and then store that total order value in a file. So in this case, we are going to print the total order value and also store that order value in a file in lakeFS repository, so we can keep track of version control that. So the only code you will add in your existing flows is something like this, where you will upload this object or upload this file, create a file and upload that into lakeFS repository, so we can version control that. So here, if you see, you're going to call this upload object, where you'll pass the credentials which are stored in Prefect block. So you don't have to pass the credentials or enter your credentials every time. And then you specify your repository name and the branch name and the file name that you want to create. So that's the only additional code that you will add in your existing flow to connect to lakeFS repository and upload that your data set into lakeFS repository, so we can version control that. And so this is the changes you will make in your existing flow. And then we have provided a wrapper DAG, where from this this flow will call your existing pipeline or existing flow. So let me just quickly show you in the end here. So what we do here is in this wrapper DAG, we create a new branch in lakeFS repository. So instead of running your job in your production, you create a separate branch. Again, it's a millisecond operation. And in this case, we specify the timestamp. So every time we run this, we'll have a new branch. Then we create a separate, create a new branch and run your existing flow. In this case, this is my tutorial or the ETL job, and run this in a separate branch. And once the flow is done, then we commit the changes into lakeFS repository, so we can keep track of all the changes happening. We can see the lineage and data evaluation. And then once the whole job finishes, everything is successful, then we'll merge that changes into production data or production branch. So just quickly I'll show you all this thing. Let's say, for example, the merge operation. Basically, you use your lakeFS credentials and call this Python client API to merge your changes. So merge into this branch. So on. This is for merge operation. This is my commit operation. So this is the wrapper DAG which we provide. So you can just use this as is to run your existing flow. Anything else you want to add? Either I forgot or missed?
No, you didn't miss, but just to organize it in my head, what we're actually saying is whatever flow you have right now, we have a wrapper that basically will create a branch, run the flow, commit the changes, merge the changes. So very quickly, you can start running the flows in isolation.
Yep. So let's run this flow. So let me run this. So submit this job or the flow into to Prefect server. So I think it just finished. It's a simple job. So also here, if you run this cell, it will create the link to go to your Prefect UI and point to that particular flow we just ran. So in this case, so here, I create this branch initially, run my ETL job. Let me make it bigger. So run my job and then commit my changes once the job was successful, and then merge my changes into my production branch. So let's look into that in the lakeFS side, how it looks. So if I go into this is my existing DAG repo, which we created. It was earlier blank. So if I go here, you'll see different branches. I just create this branch to run my ETL job. And then once the job was successful, I merge that into my main branch. So if I go into my main branch now, I can see this file exists now, which is the total order value. And if I go into my commits, you can see all the changes that happen. In this case, it was just one single commit and single merge operation. But anytime if you go into the commit details here, you will find you can attach a lot of metadata into your commit when you commit data into lakeFS, and you can see this was this was the commit, this file was committed into lakeFS. And from here also, you can go straight to the Prefect UI. So when you are trying to troubleshoot a problem, so let's say if you start from Prefect UI, you can come to lakeFS, or from lakeFS, you can go straight to the Prefect UI. So if I go into the UI here, it will tell me this task or this flow in Prefect created that particular commit. And you can see here in this information, this URL, so it can take you straight to the commit in lakeFS. So it's a both-way integration that we provide. So if you are trying to troubleshoot any problem in Prefect, you can get this URL and go straight to lakeFS commit for that particular task that you did. Or if you are looking at data in lakeFS, from here you go straight to the task which created this commit. So we provide both-way integration.
So I mean, there's a question about the wrapper in the chat. Does the wrapper run separately as well?
So wrapper is kind of a separate flow running, and the wrapper calls your existing flow. So instead of scheduling your flow, you'll schedule your wrapper, and wrapper will call your existing flow. So
and it's worth mentioning that you don't have to do it this way, right? You can have just one flow that will take care of this. This is just an easy getting started kind of way, right? I already have my flow. I don't want to change it. Let's just wrap it in a branch. So whatever we have, we're going to run in isolation and be able to commit, roll back, atomically promote, etc.
Yep.
And one thing about integrating Prefect here is that whenever you do wrap your code, if you notice that some of the flows, they don't have to be inherently scheduled. Anytime they're run, anytime they're triggered from anywhere, whether it's a separate flow or triggered elsewhere, you'll get all the observability that Amit showed in the UI. So anytime you are debugging, you can view not only the logs, but also the artifacts generated that will probably tie to anything in lakeFS, as well as the parameters that actually generated the data, which help give context as you are debugging.
Yep, that's very helpful. Thank you, Sarah. Okay, so that was one example using your existing flow.
Sorry, I think we're having a continuous conversation about that question. Sorry, which is fantastic. Thank you. Keep them coming. Do we have synchronized data and Prefect code commits?
Do we have synchronized data and
the way I read this question is that how can I match between the Prefect code that was running and the data that was there, but I might not understood the question correctly.
So sometimes people keep their Prefect code maybe in a separate Git repository and commit that code in a separate commit, and while data is committed in lakeFS. But I think he said that your understanding was correct, though.
Yeah, which to me that's exactly where you're going with this. So lakeFS will typically be used for versioning your data, but what we do is we add metadata describing commits. One metadata describing a commit, a generic one that you definitely saw here, is the link to Prefect. Right, so when we went and we looked at the lakeFS UI and we saw this button that took you to the Prefect UI, what that actually is metadata of a commit, metadata of a data commit. Very common use case will be to add as a metadata of a commit also the code version, like a GitHub link, right, that was used there. So that will be the way that people do that. Awesome.
Yeah, you can include here in the metadata your code version also.
Yeah, and if you put since we're talking, if you see you see that it's named kind of weird, : lakeFS : Prefect : URL UI. Any metadata that you write in that I don't know format, that's the right word. Like if I replace the word Prefect with GitHub, then that will automatically create a button that will say open GitHub UI, and we go to the value of that code. Kind of an expert tip for lakeFS.
Yeah, that's the trick to create these buttons. Anybody can add their own button pointing to wherever their code is. Okay, so that was the first example. So let's talk about the next one, which is where you have a complex flows. You want to commit after each task is done and run things in parallel also in different branches. And once all those things complete, then you merge into one separate branch and then merge into production. That gives you better linears, and it makes it easy to troubleshoot a big ETL job or big job. So I'm not, this is another example demo here, a notebook here. I'm not going to run the whole thing. It will, because it takes some time, like to run about 10 minutes, but I'll quickly walk through here. I already ran this ahead of time. So for this, I have this repository, Prefect new DAG repo. I think I showed this earlier. And here again, you specify your credentials and storage namespace, create your repository, new DAG. Can store your credentials in the Prefect block, run your setup task here to create the repository, and then you run your task here. In this case, I'm not using wrapper DAG. It's a one program where I'm doing all those operations in that same program. So let's quickly look into that. Here, I'm doing everything using Python. Create my ETL branch. You'll see I'm creating different branches here to run those different tasks in parallel, like load my data set, run my task one. These are just sample tasks I'm running. In this case, just doing some processing, and create different tasks running in parallel. Commit my changes after each task. So you can look into this as more details later. And then finally merge all my changes, merge into each task into the main ETL job branch, and then merge the main ETL branch to the production branch. And if you see here, you'll see the full connection between different tasks as I am linking all those different tasks together. Okay, so once you run this, and in this case, we are using a sample CSV file, which is also included in this container. And now if I go to that particular run, so I already have this open here. It's a little more complex job here. So let me maximize this and quickly walk through here. Again, here I'm running these things in different tasks. So if you look into more detail here, each task is running in a separate kind of flow, and then within that, I'm committing all the changes into lakeFS repository. So if I go back to my lakeFS repository, you can see for each run, a separate task, I'm creating a separate branch. So I create my first ETL load branch. Within that, I create a separate 3 branches to run my different tasks in parallel. So all those things are happening through the code, which are creating separate isolated environment to run that code. So so this is a successful run. Everything worked fine. So it's easy. But let's say something fails. So in this example here in demo, we have provided another CSV file, which is a bad file. So the first file, when you run, it is a good file and the job runs successfully, fine, everything. But also include, let's say you get new file or latest file, and that file is somehow is bad, which causes your job to fail. And if you run that job with this particular file, and in this case, for example, you get some error message here. Let's see, just quickly. And I'll also open this in the Prefect UI. So in this case, when you are processing the file, it gave some problem. The error message here, there's some certain schema is wrong with this file, with this CSV file. So let's look into the the issue which happened, how to troubleshoot. That's most important part to show in this demo. So, like, let's say this is the same flow, but with the new file, with the latest file, we got some error message here. So this particular task failed. So let's click on that. So I want to see what happened. What was the data looked like at that time when this task failed? So if you look too quickly, the task before that was creating a branch, a separate branch here. So let me maximize this. So before the task failed, I created a separate branch to run this particular task. So I can look into that and go into my on the lakeFS side and see how my data look like when the task failed. So let me open this. So this is the create branch operation just before the task failed. So you don't have to look into all the tasks that happened before that. Just look at the task which happened before that and what was the data look like at that time. So again, when you go to that task, you can just get this URL, lakeFS URL, then just take this and it will straight away take you to the commit that you did for that particular task. So this is the branch it created to run that task. And you can see this is your latest file. This was your original file. So you can quickly look into, again, this is running in isolation. This is not in your production. So in your production, you won't see this file. This is a new file, which is only in this particular branch. So you can look into how the original file looked like. In this case, simple example, this file has 5 columns, single record. But the new file, if I look into, this has only 4 columns. That's what the other message was complaining about. The schema is wrong because it has only 4 columns instead of 5 columns. So that way, when the job fails, to quickly troubleshoot, you can get the link from the Prefect log, come to lakeFS side, and see how your data looked like at that time when you ran that task. And again, there's a lot more information available here. So if you go into this file, it will provide you all the object information and as well as the blame functionality. So it will tell you the parent commit also. If you're familiar with the Git commits, so it will tell you the current commit information as well as the parent. You can go to the parent and see how it looked like. Again, from here, you can traverse back to the Prefect UI also. So that's how you can quickly troubleshoot if anything goes wrong, how the data looked like when the problem happened. Anything else, Ido, you want to add?
That was a lot. Thank you so much. Incredible demo. Maybe I'll take sharing from here.
Yep.
And am I sharing the right screen this time? Yeah, it looks like I am.
Yep.
So look, folks, this was a lot. So it's also we'll share the recording, but it's also documented. Oh, sorry. It's also documented, and we have a step-by-step instructions available for anybody that wants to do this from start to finish, available on our blog. So feel free to take a look into that. Secondly, it's worth mentioning that everything that we show today is a part of lakeFS open source. We're an open source solution with an open core approach, meaning there are no artificial limitations. There's no like up to 5 pipelines, up to 26 kind of thing. So you can use this at scale with your lakeFS open source solution. Of course, we also have a SaaS solution or an enterprise solution with some more enterprise features available for those who are interested. And since we used Prefect OSS, I assume that everything that we saw here was also available in Prefect, but I'll ask Sarah.
Yes, we echo the approach of lakeFS. Everything that you saw is open source. All the orchestration features, as well as the logging, all of that is fully free and open source. We also follow the open core approach. But I will ask the question of listeners, maybe this is a rhetorical question of, okay, well, what if you want to react to any sort of failure? So you can debug in lakeFS, but what if you need to run some sort of backup if a failure occurs? That's one of the reasons why you might consider moving to Prefect Cloud, where you can ingest external events, you can build automations from them to either react to a flow or also trigger a flow in that way, as well as kind of very fine-grained access control and scalability features as well. So there is a free tier of Prefect Cloud, so do try that out.
Awesome. Thank you. And the last thing, as we are in a community, we're fortunate to have an incredible Slack community. We with, over 1,000 companies that we are aware of that are a part of this, and 4,000 members. You can see the link to the lakeFS Slack community right here, right next to the link to the Prefect community as well. So would love to see you there. Please feel free to join. I will wait just a few more seconds here to see if anybody has additional questions. See, we have something coming up. Is there any problem when merging pre-prod with prod in case prod data continued with changing prod data? That's a fantastic question. Specifically, I'll broaden it and I'll step back and I'll ask, what about conflicts? How do you, so Amit, maybe you want to take the first stab of it. How do you manage conflicts if something changed already in your environment and now you're trying to merge new data?
Yeah, so we have the strategy when you merge, like whether the source wins or the target wins. So if something changed, what changes you want to keep. And also we have another example or sample where you can backfill. So a lot of time what happens when you're running ETL job in parallel, some additional data might come into in the prod. So you might do a backfill of that. So there's another example to explain that.
Yeah, I think in general, conflict resolution is built into lakeFS. You can decide how you want to do it. And furthermore, you can, there's a lot of techniques to do this, but it's handled as a part of the system. Happy to go into more details about how to separate things and things of that nature. Let's see if there's, I'm going to see if there's any other questions.
You want to go back to that slide with the QR codes so people can?
Yes, sir. Here we go. See if there's any additional questions. Going once. Going twice. Awesome. This was a lot of fun. I want to thank you again, Amit, and thank you again, Sarah. It was great having you here. I think you contributed a lot. So happy to have our partners here with us. So thank you.
My pleasure, and great webinar, and appreciate all the listeners for tuning in.
And thank you everyone for joining.
Bye-bye.